3.3 is an ellipse, and again, we're talking about a conic section. And in this conic section, if you cut it at this angle, it's going to make kind of an oval shape or an ellipse. Your equation looks like this, or it looks like this. And without the numbers in there, it's hard to tell what's happening. But what's going to happen is going to be the difference between if it's elongated in the x direction or in the y direction. And so typically what's going to determine if it's an x, stretched in the x or stretched in the y is which of these numbers is bigger. So when this number is bigger, it's stretched in the x direction. Notice this number goes with the x number. And when this number is bigger, it's going to be stretched in the y numbers, in the y direction. So notice, pay attention to which number is bigger, and that's how it's going to be stretched. If those numbers would happen to be the same, they would be stretched the same, which would not make it an ellipse. It would make it a what? That'd be a circle. Okay, so that could happen. You might see that come up. If they're stretched the same, that's going to be a circle, though. If one of them stretched more, it's stretched in that direction. So we've got a really complicated looking drawing. Again, we've got some points. This time we've got 2 points marked with F, and the plural of focus is foci. All right, plural of focus is foci, and the foci are going to be lying in the direction that the thing is stretched. So here, over here, you've got the 2 foci, and that's going to be marked with the letter C on the drawing, but C is going to be the distance between the center of that ellipse and the foci. You've got this equation right here, and this is going to be very important. So box that in. C squared equals A squared minus B squared. Notice how it kind of reminds you of Pythagorean theorem, but not quite. All right, you got to pay attention to that little bitty detail. A is the distance from the center to the vertex. B is the center to the what's called the co-vertex. So you got to notice which one's longer. From the center to the vertex is A. From the center to the co-vertex is B. All right, so that's just little bitty details that you have to pay attention to and you have to understand, and everything else falls into place after that. Example 0, find the coordinates of the center, vertices, co-vertices, and foci for this equation. All right, so the center should be easy because it's the exact same thing as what we've done in the past. All right, for the center, we're looking at what number makes 0. Well, x equals 1 makes 0, and y equals -2 makes 0 right there. You can see it, and so we know the center point is the point 1, -2. Right, the vertices, the co-vertices, and the foci. To me, I almost always want to make a little sketch. Okay, and if you look at the formula, whichever bigger number corresponded with A, but specifically it was A squared. That number would be A squared, and so you could see pretty quickly that A equals 5, right? Square root of 25 is 5, and so over here B squared, that's the smaller number, and so square root that to find B is 3. I can use that information to draw a sketch, and it doesn't have to be an awesome sketch, but I might draw a quick little sketch. I know the center is at 1, -2. So let me just draw this. It's oriented in the x direction, so I know it's stretched more in the x direction than in the y direction because that number's bigger. But anyway, I've got +1, -2. I'm just going to put a point right there, and I'm going to call that 1, -2. And I don't even really need tick marks. Okay, I don't even really need tick marks. But since that A number goes with the x number, I know I'm going to go over 5 in either direction. That's 5, and that's 5, right? And so there's going to be a point there. 5 on either side of that vertex. And so I guess if you did a tick mark, this was x equals 1, and you go over 1, 2, 3, 4, 5, this would have to be at 6 now, right? And if you go in the other direction, 1, 2, 3, 4, 5, that should be at what, -4? If you go 5 away from 1, which was the center, 5 in either direction, because that's your distance. Okay, so I can see right now that my vertices are going to have the coordinates -4, comma, -2, and +6, -2. Those are the vertices. -4, comma, -2, and +6, -2. But then I can go in the other direction. In the shorter direction, if I go in the shorter direction, 3, I would go, okay, this is at, what was that, -2? So count 1, 2, 3, and there's going to be a point right there. That's a distance of 3 away. And those coordinates would be, what, 1, 1? And if I go down 1, 2, 3, there's going to be a point right there. It's a distance of 3 that way. And those would be the coordinates 1, was that 1, 2, 3, 4, 5, -5. I've got co-vertices at 1, 1, and 1, -5. Notice my vertices are changing the x number because it's stretched in the x direction. My co-vertices are changing the y number because that's the y direction. But the result, by finding those dots, is my ellipse. All right, that's not awesome, but that's the ellipse. It's stretched in the x direction. Now for the foci, that's a little bit harder. You're going to have to use that equation. All right, so foci, you're going to need c squared equals a squared minus b squared. Well, a squared was 25, and b squared was 9. 25 minus 9 is 16. C squared equals 16. Square root. Now, technically, the solution to that equation is plus or minus 4. There are two solutions to that, plus or minus 4, but we're talking about distance. Okay, we're talking about distance, and so we just use the positive version. But it's 4 away from the center. It's the distance between the center and the foci. So if you go over 1, 2, 3, 4, that's the focus point. And in the other direction, 1, 2, 3, 4, right there. That's the other focus point. Focus, focus. Those coordinates would be what? 1, 2, 3, 4, 5, comma, -2. And 1, 2, 3, -3, -2. Right there. That's how everything works. If you understand that, then you understand most of the lesson. Graph each ellipse, find the coordinates of the foci, and give the domain and the range. All right. So I didn't give you graph paper here, I don't believe. And so that's fine. We can just do a quick little sketch. But one thing you need to pay attention to, and this is one of those little details that you have to notice, is that in our equation of an ellipse, it's always going to equal 1. All right. So that's kind of a big deal. We want it to equal 1. And so when I look at this example, it's a little bit tricky at first because it doesn't equal 1. It doesn't equal 1, and we also don't see that fraction that comes out. But all I'm going to do is I'm going to divide both sides by 100 to force it to equal 1. So I want to divide by 100 so that I can equal 1. And over on the left, you've got 4 over 100, and that reduces to 1 over 25. So this x squared part is going to be x squared over 25. Now, likewise, with the second fraction, it's 25 over 100 which is going to reduce to 1/4. So I'm reducing my fraction. That's going to be plus y squared over 4. I've got 4 over 100 reduces, and I've got 25 over 100 reduces equals 1. That's my equation of my ellipse. All right. So the first thing you always want to do is find the center point. And the center point has to do with what makes this and this 0. Well, this one is 0, 0. The center of that thing is 0, 0. And you can see this is stretched in the x direction with a equal 5 and b equal 2, like that. So if I was going to draw this, if I was going to sketch this thing, I would start out and locate the center point, 0, 0. And then I'm going to need to go over 5 in the x direction. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 2 in the y direction. 1, 2, 1, 2. I can put dots down there. And draw my ellipse. That's not perfect, but it's pretty good. Do your best to draw it nice and symmetrical. All right, we want to find the coordinates of the foci. So the foci, that's what we need that c squared equation for, right? C squared equals a squared minus b squared. A squared was 25 and b squared was 4. And so c squared equals 21. C squared equals 21. And that means when we take the square root, ignore the negative square root, we're going to do the square root of 21. And square root of 21 is about 4.6. So what that's saying is the distance from center is about 4.6. That's how you're going to locate it. That's how you're going to graph it. We don't know how to conceptualize square root of 21. I don't know what that means. You might be able to place it somewhere between 4 and 5, but it's about 4.6. So I'm going to go over about 4.6 and put a dot down here, and over 4.6 in the other direction and put a dot down there. That's where your foci would be. So I suppose you could say your focus points are going to be at about 4.6 comma 0 and negative 4.6 comma 0. But it's going to be a lot better if you're exact. And instead of saying 4.6, say square root of 21. That's square root of 21 comma 0 and negative square root of 21 comma 0. It's a little bit easier in this case because it's centered at the origin. If it was centered somewhere else, it'd be a little bit harder math problem. But for now, that's what we have to do. That's the foci. So give the domain and the range. Domain, remember, squash it onto the x. Look at the x numbers that are covered. It looks like the domain is taking us from negative 5 to 5. Brackets mean we could equal 5. The range is taking us from negative 2 to positive 2. Remember, always start with the smaller number and end with the bigger number. So then the next one, it's basically the same idea. We're going to divide by 441 this time. So 49, you've got to reduce two fractions. You've got to reduce 49 over 441. 49 goes into 441 9 times, I believe. So that just reduces to 1/9. You've got x squared over 9. And so then divide by 9, you get 49. Y squared over 49 equals 1. Again, we want 1 so we can really see the ellipse and so we can see which direction this is stretched. Do you know if this is stretched in the x or in the y? Y. It's going to be taller this time. It's going to be taller than it is wide. We can see the vertex again. or not the vertex, the center. The center is at 0, 0 again. And you can see that this number is going to be 7, and this number is going to be 3. It doesn't even really matter which one's A and which one's B, as long as you understand that it's going to be 7 in the y direction. That 7 goes with the y direction, the 3 goes with the x direction. That's how it's stretched. So when we draw this graph, this one is going to be centered at 0, 0, and we're going to go up 7. So that would be the point 0, 7. And we go down 7, and that's going to be 0, negative 7. We're going to go over in the x direction 3, so that's 3, 0. And negative 3 gives me negative 3, 0. I don't need tick marks to see what that's going to do. All right. But when I want to find the foci, that's where I need this equation. C squared equals A squared minus B squared. A squared was 49, it's the bigger number. B squared was 9, so that's 40. C squared equals 40. So we need to do the square root of 40. And you can simplify that one. 4 times 10, 2 radical 10. C equals 2 radical 10. Now, if you're like me, you have no idea what that means. Square root of 40 is bigger than square root of 36, so I know it's 6 point something. I know it's 6 point something. But you might as well just type it in and see 6.3 about. We're talking about 6.3. So we need to go 6.3 in this direction and 6.3 in this direction. Those are your focus points. 2 of them. Focus points. What are the coordinates? Well, this one, the x coordinate is 0, and the y coordinate is, you could say square root of 40, you could say about 6.3. It'd probably be best if you said that's 2 radical 10. And then there's this one, which is 0 and minus 2 radical 10. Why did I need the 6.3? That just helped me know where to graph it. Domain. Domain is the x, right? Domain is the x. And if you look at this, it goes from negative 3 to positive 3. Range is the y. Looks like it goes from negative 7 to positive 7. Now, one other thing that they might talk about is like a major axis and minor axis. And you might have to come up with something called a major axis or a minor axis. It didn't ask, but major axis is the longer axis. See how this is, what is this, 10? That major axis has a length of 10, and this major axis has a length of what, 14? 14. And then there's a minor axis, and it's just the short one. This minor axis is 4, and this one would be 6. So the longer one is the major, the shorter one is the minor. Yes? Okay, A is 7. A squared is 49. And the A term, did I mess that up? Okay, so when you're looking for A squared, it's always whichever one's bigger. So that's confusing because sometimes it's over here under the X and sometimes it's over here under the Y. So don't pay attention to which one comes first and which one comes second. You got to pay attention to which one's bigger. In some ways, it doesn't really matter. Just take big minus small and think of it that way. But yeah, as far as which one's A and which one's B, it's the bigger one is A and the smaller one is B. Okay, good question. Thank you. Number 2, write the equation of the ellipse having center at the origin foci at negative 5, 0, and 5, 0, and a major axis with length 18 units. All right, so I find a lot of students won't draw a picture if it doesn't say to draw a picture. But honestly, sometimes that's the best thing that you can do. I know the center is at 0, 0, and they give me some other information. I think the easiest thing to do, the best thing that you can do, is draw a picture of what they give you. All right. So I know the center of this thing is at 0, 0. And then they say it's got a focus. It's got foci at negative 5, 0, and 5, 0. So 1, 2, 3, 4, 5 is a focus, and negative 1, 2, 3, 4, 5 is the other focus. That tells me which direction this is stretched. This is stretched in the x direction, okay? Because the foci are on the x-axis or in the x direction from the center. I know this is longer. I know this shape. It's an X, okay? So what else do they give me? Well, they give me the major axis is 18. The major axis is 18, the longer axis, okay? From here to here is 18. Now, it doesn't seem like they give me very much information, but that should be plenty, okay? The center being 0, 0 tells me that this is just going to be x squared plus y squared. So I need the a squared and the b squared numbers for the bottom of those two fractions. All right, so let's look at what they give me. They give me this distance right here is 5, right? And the distance to the focus is the letter C. I know that C equals 5 based on what they told me. And maybe you could figure that out from the words that they gave you, but it makes it a lot more obvious to me once I look at the picture. But when they gave me that major axis, they gave me another important piece of information. I know that this distance right here is A. And I can tell from this picture that A equals 9. All right. A equals 9. That's half of 18, right? Half of 18. That's 9, and over here's 9. 9 plus 9 is 18. That's the major axis, okay? So I know A is 9. That must mean that this number right here is 81. A squared is 81. I don't have my B number, though. I don't have my B number, but that's fine. I can use my formula, right? I know that formula says C squared equals A squared minus B squared. And C squared, 5 squared is 25. C is 5, so square it, you get 25. A squared is going to be 81. 9 squared is 81. And you just have to solve to find B. Or B squared, actually. I don't even really need B. I just need B squared. So what? Subtract 81. 25 minus 81 is negative 56 equals negative B squared. So that means B squared equals 56. And you could do the square root to find, you could find B, but I don't really need to. I want B squared. I want B squared. Right there. B squared is 56. That's what goes in the equation. I'm done. That's it. That's the equation. Okay, number 3. Graph this, give the domain and the range. All right, well, it's not at all obvious what in the heck this looks like. Okay, it's not at all obvious that this is an ellipse when you look at it. You could probably take it over to Desmos and plug it in and it'll graph it. It won't do what you expect, though, probably. But anyway, I really would like for this one to look more like my standard form. And that square root is kind of giving me fits. So probably what I would do in this case, I want to get rid of the square root. I can do that if I square both sides. Let's square both sides. Y squared over 9 equals, negative squared is going to be positive, it goes away. Square root squared goes away. Basically all that stuff goes away. Give me 1 minus x squared over 4. That looks a lot more like what I want it to look like. Only difference is that x squared term, I'm going to add it over to the other side. Okay, so let's take this term and add it over here. So it becomes x squared over 4 plus y squared over 9 equals 1. Okay, check it out. Now that looks like an ellipse, right? That looks like an ellipse. And who can tell me what A is in this problem? What's A? What? 3, very good. A is going to be 3. It's the bigger one. And B is 2. Sometimes people will just say 9 and 4, but that's the A squared and the B squared. So that should tell me how to graph this thing, okay? But something weird happens here. You don't really want to graph the whole thing because of the way the original equation was. So if I was going to graph this thing, the center point is a 0, 0. And so we can graph this thing, center point is 0, 0. And the major axis is the y-axis. So you would go like up 3 and down 3. So up 3 is here and down 3 is here. And the minor axis go over 2. 2 and 1, 2. Look like this. And so normally we would just draw our oval through those 4 points. But the thing that's weird here is if you look at the original equation, it says y over 3 equals negative something, right? It's only taking the bottom half of the ellipse, all right? We are definitely going to be, y over 3 is definitely going to be less than or equal 0. So if you multiply by 3, you can see that y is less than or equal 0. Instead of taking the whole ellipse, you're only really drawing the bottom half of the ellipse, which is kind of weird. It doesn't want the top half. All right. Think about when you do a square root, you've got a positive and a negative root. A positive and a negative root. Well, we just have the negative, and so we have the negative part of the ellipse. Tricky. You can check it on Desmos though. Plug in the original equation. I bet you get the bottom half of an ellipse. Domain. X numbers go from -2 to 2. Range is the y numbers. Looks like it goes from -3 to 0 in this case. All right, number 4. Graph it, give the domain and range. First thing you want to do is find the center. So where's the center? 3, 0. Very good. 3, 0. So 1, 2, 3, 3, 0. There's your center point, right? Second thing you want to do is find A and B, all right? A is going to be 6 and B is going to be 3. But you want to pay attention to which direction this is facing. Is this going to be stretched more in the X direction or more in the Y direction? More in the X direction, right? All right, so what you do is you go over 6 from the center. You don't always start at the origin. Every example we've seen so far starts at the origin, but this one doesn't. You start from the center and you go over 1, 2, 3, 4, 5, 6. Now we're at 9. Or the other way, 1, 2, 3, 4, 5, 6. Now we're at -3. In the y direction, you need to go up or down 3, right? So we're going to go 1, 2, 3 in the y direction from the center, 1, 2, 3 in the y direction from the center. Can draw an ellipse right through there. We should be able to give the domain and the range. Domain goes from what to what? -3 to 9. And the range, my picture doesn't look awesome. -3 to 3. Okay, very good. Now, it doesn't ask me for this, but you know, the harder questions are going to ask you extra questions, like major axis. That major axis is just going to be 6 times 2 is 12, right? Because if you go over 6 this way, or if you go over 6 this way, it's going to be 6 plus 6. It's going to be 12. The minor axis is going to be what? 6, because we went 3 up or 3 down. The minor axis is 6. Okay, it's just the length of the long ways or the length of the short ways. Yes. Okay. Oh, save it. We'll have to go back to the last one. Okay. The other thing that they might ask is something about the foci. If you're talking about the foci, you're talking about this: c squared equals a squared minus b squared. And so a squared was 36 and b squared was 9. Subtract there is 27. So c is the square root of 27, right? And we can split that up even. 9 times 3, that's 3 times the square root of 3, which is pretty tough, really, to find the coordinates of the foci. We can see the square root of 27 is about 5.2. And so what that means is you'd go over 5.2 from the center. So from the center, you're going to go, where are we at? 1, 2, 3, 4, 5.2 is about right there. Or negative 1, 2, 3, 4, 5.2 is about right there. We can draw them, but the coordinates is a little bit weird. If I asked you for the coordinates of the foci, what did we do to get there? We took that center number 3 and we added 3 square root of 3. Your y coordinate was still 0. That's one of your focus points. Then over here, what we did was we started at the center at 3 and we subtracted that number, 3 square root of 3, and the y coordinate was still 0. I know that's one of the hardest things to do. All right. Let's finish up. I think one more slide. Whoops. Eccentricity of an ellipse is a measure of its roundness. A circle is perfectly round, but an ellipse is not. Okay, ellipse is roundish, right? And it could be, if it's the more stretched it is, the less perfectly round it is. And there's a formula for that. E for eccentricity equals C divided by A, where C and A are the same things as what we had before. So when this says number 5, find the eccentricity of each ellipse, it's basically saying how round is it? How round is it? So I can do A here is 10 and B here is 9. And in order to use the formula, I'm going to need C. So remember, C squared equals A squared minus B squared, right? A squared minus B squared. That's 19. So C squared equals 19. C, we're going to take the square root and get the square root of 19. Question? So now we use our formula. E equals C over A, square root of 19 over 10. I'd use a calculator here. Square root of 19 over 10, 0.4359 or so. So about 0.4359. That's how round is this? Okay, how round is it? So then part B, same thing. Whoa. You can see that A is the square root of 11 and B is the square root of 6, but you have to find C. And so C squared equals A squared minus B squared. That's 11 minus 6 is 5. So C is going to be the square root of 5. We have to find C so we can plug it into our eccentricity formula, E equals C over A. That's square root of 5 over square root of 11. About 0.6742. And so when we compare those two numbers that we just found, or two answers, we can tell which one is closer to round, which one is a better, which one is closer to round. So let's look at a circle just to make sure. I think I might have told you something wrong, so this will be enlightening maybe. If I say x squared over 4 plus y squared over 4 equals 1. It's stretched the same amount in the x and the y direction. That's going to be a circle. That's a perfect circle. So it's hard to tell which one's A and which one's B, but either way, it's got to be 2, right? Neither one's bigger. So if I try to do the same formula, A squared minus B squared, that's going to be 4 minus 4 is 0. So in this case, if C squared equals 0, that means C equals 0. And my eccentricity formula, C over A, is going to be 0 over 2. So E equals 0. So it looks like an eccentricity of 0 is a perfect circle. So that generally would tell me that the lower the eccentricity number is, the more circular it is, right? Think about the word eccentric. It means like crazy or off, right? So we want it to be the least amount of crazy. The lowest amount of E is the better circle, or more circular, I guess.